Welcome to my channel. So in this video we are going to discuss about the remaining 20 questions from the unit 1 of the subject transmission lines and RF system and transmission lines and waveguides. Okay, so already we discussed the first 20 2-mark question from the first unit. Okay, so if you want to learn that video means I will give link in the description box, you can refer it. And if you want to learn the lecture videos for the subject in my channel, in the name of transmission lines and RF system, one playlist is there. In that playlist, the complete full videos with the related problems in all units is solved. Okay, if you want to learn that, I will give link in the description box, you can refer it. Okay, so now we will discuss the remaining 20 questions from this unit. Okay, the first question is that a transmission line has the characteristics impedance 400 ohms and it is terminated by a load impedance 650 minus J475 ohm. Determine the reflection coefficient. Okay, so it's a very important question. This type of 2-mark question you may compulsory receive from this unit. Okay, from this unit as well as the second unit also. Here the question is reflection coefficient. So first you should know the formula for reflection coefficient. The reflection coefficient K equal to ZR minus Z0 by ZR plus Z0, where ZR is the load impedance, Z0 is the characteristics impedance. So here you see in our question the characteristics impedance, it is given as 400. So characteristics impedance notation you know Z0, and the load impedance you may use ZL or ZR. Okay, it is 650 minus J475. Okay, these are the given data. Our aim is to find out the reflection coefficient. So first we have to write the formula K equal to ZR minus Z0 by ZR plus Z0. Okay, so you substitute the thing. So ZR is 650 minus J475 minus 400 divided by the addition of the two things. Okay, so in this you just add the real part first. So here you see real part 650 minus 400. So you just subtract it 250. Then this imaginary part you just write it minus J475. Similarly in denominator 650 plus 450. Real you add 1050 minus J475. Okay. Then here you see the numerator and denominator. It is in complex quantity. Okay, rectangle form and rectangle form. So using calculator, you just convert, you just do the division for this rectangular quantity and you find the answer in rectangular form. That rectangular form you just convert into polar. You may get the answer is 0.4657 with angle minus 38.08 degree. Okay. So therefore, the modulus of the reflection coefficient is this one. Okay. This 0.4657 is a magnitude value and minus 38.08 degrees is the angle. Okay, so this is the reflection coefficient. Okay, calculation. Or in order to convert, okay, in our calc if complex mode is not available means, so you just convert this numerator 250 minus J475 into polar and the denominator you just convert into polar. Okay, then you divide. So the magnitude of polar you divide, you may get 0.4657 and the angle we have to subtract it. So the answer is minus 38.08. Okay. So this is the in two way you can solve, we can get the same answer only. So this is the important problem from this unit. Okay. And the next question you see, find the reflection coefficient of 50 ohm transmission line when it is terminated by a load of 60 plus J40 ohms. Okay, so in this case also the same thing, we have to find the reflection coefficient and characteristics impedance is 50 ohm, load impedance is 60 plus J40. Okay, so you just substitute in our K formula ZR minus Z0 by ZR plus Z0. So we may get this thing. Then you just divide rectangle by rectangle and that rectangle answer you just convert into polar. You may get the answer 0.3522 with angle 55.98 degree. Okay, so this is the question. Then the next question, this is also a very important repeated 2-mark question, 2-mark problem from this unit. If ZOC means open circuited impedance is 750 with angle minus 30 degree, and a short circuit impedance 600 with angle minus 20 degree of the two-port network. Find the characteristics impedance. This is the question. Okay, so already you know the relation between characteristics impedance and open circuit impedance and short circuit impedance. Okay, the Z naught equal to square root of ZOC and ZSE. Okay, this is the relation. That is, if you are multiplying the open circuit and short circuit impedance, we may get Z naught squared. So therefore, Z naught equal to square root of this. Okay, so here you just substitute the thing. ZOC 750 with angle minus 30, 600 with angle minus 20. So here two thing is in polar. So the magnitude of this two polar quantity you just multiply. So 750 into 600 you multiply and you take square root. So the answer is 670.82. Okay, and angle you just so here it is multiplication means the angle you just add it. So minus 30 minus 20 minus 50. And this angle is in square root, under square root. So that's why minus 50 divided by 2. So minus 25 degree. So the characteristics impedance is 670.82 with angle minus 25 degree. So you may convert this characteristics impedance in polar to rectangle also. Okay, so you may convert into rectangle format, real plus imaginary, you just convert. If you want means you just convert. Or otherwise, this is the characteristics impedance value. Okay, so this is also here one of the important repeated 2-mark problem from first unit, as well as similar to this in second unit also one more problem is there. Okay, and the next thing, the question, what is the drawback of using ordinary telephone cables? Okay, so in ordinary telephone cable, the wires are insulated with paper and twisted in pair. Okay, so you know that is the structure of telephone cable. So therefore, there will not be flux linkage between the wires. Okay, so that's why which results in the negligible inductance and conductance. So in this case, there may be a frequency and phase distortion occurred in the transmission line. Okay, so this is the drawback of transmission line. So in a telephone line, we may get the frequency distortion as well as the phase distortion. Okay, then how the telephone line can be made distortion less line. So in order to make a telephone line as a distortion less line, for telephone line to be distortion less line, the inductance value should be increased by placing the lumped inductors along the line. Okay, if you want to make the telephone line as a distortion less line, we have to increase the inductance value by placing additional inductors along the line. Okay, this is the concept. Then what is loading? So loading is a very important process in transmission line. Okay, in order to avoid the distortion. So loading is a process of increasing the inductance value by placing the lumped inductor at a specific interval along the line, which avoids the distortion. So in order to avoid the distortion in transmission line, we are using the process loading. So loading means in order to increase the inductance value, if you want to avoid the distortion, we have to place lumped inductors at specific interval along the line. That process is called as loading. Okay, then what are loaded lines? To achieve the distortion less line in transmission line, the inductance value has to be increased. So that that line is called as loaded lines. Okay, then what are the types of loading? Okay, there are 3 types of loading: continuous loading, patch loading, and lumped loading. Okay, these are all the 3 types of loading. What is continuous loading? The continuous loading is the process of increasing the inductance value by placing iron core or magnetic tape over the conductor of the line. Okay, it is called as a continuous loading. And the next type of patch loading. What is patch loading? It's a process of using sections of continuously loaded cable separated by section of unloaded cable with increases the inductance value. So this type of loading is called as a patch loading. Okay. Then what is lumped loading? Lumped loading is a process of increasing the inductance value by placing lumped inductors at the specific interval along the line. It is called as a lumped loading in order to avoid the distortion. So anyway, the continuous loading, patch loading, lumped loading, these are all the three types of loading in order to avoid the distortion in a transmission line. Okay. Then the next thing, what are the conditions for perfect line and what is smooth line? Okay, so the perfect line means, so for a perfect line, the resistance and leakage conductance value is neglected. Okay, that means, so for a perfect line, the resistance value as well as the conductance value, it becomes negligibly zero. That line is called as a perfect line. Okay, a smooth line is one in which the load is terminated by the characteristics impedance. So at the time we may not get any reflections in a line. That a line is called as a smooth line or flat line. Okay, so already we discussed the smooth line question in the previous video also. Okay, smooth line, what is smooth line? It is also a important 2-mark question. It is a hypothetical line which has the input impedance equal to the characteristics impedance. Okay, so that is also one of the definition. So the smooth line is nothing but it's a line is terminated. Okay, line in which the load is terminated with characteristics impedance means that line, it will not have any reflection. So that line is called as a smooth line. Perfect line means a line without loss. The resistance R and G value 0 means it is called as a perfect line. Okay, then what is impedance matching? So impedance matching is a very important thing in while designing the transmission line. Okay, if the load impedance is not equal to the source impedance means then all the power or transmitted from source will not reach the load end. Okay, so some power is wasted. If the load impedance is not equal to the source impedance, so all power will not be delivered to load, some power is wasted. Okay, this is called as a impedance mismatch condition. So for proper maximum power transfer, we have to match the impedance in sending and receiving end. We have to be matched. So that process is called as a impedance matching. Okay, so the process of matching the impedance in between the sending end and receiving end, it is called as a impedance matching. So in order to provide the impedance matching, we may use single stub, double stub in between the transmission line in a proper location. Okay, so that we will discuss in the third unit. Okay, when reflection occurs in a line, so the reflection occurs because of the several cases. One is the line end is open circuited. Then another one, if the transmission line is short circuited in a load end, when the line is not terminated with the characteristics impedance. So under these conditions, the reflection occurs. Okay, reflection means, a part of sending wave again reflected back to the sender. It is called as a reflection. So reflection occurs either if the line load is open circuited or short circuited, or the line is not terminated with the characteristics impedance. Okay. Then the very important question, reflection coefficient. Okay, reflection coefficient, it can be used, it can be defined as the ratio of reflected voltage to the incident voltage at the receiving end. Okay, so how much voltage reflected divided by how much voltage incident in a load, that ratio we are calling it as a reflection coefficient. It is denoted by K. So the value of reflection coefficient is always between 0 to 1. Then the next thing, define reflection factor. So it is also one of the university question. Reflection coefficient is different, reflection factor is different. Okay, the ratio of current actually flowing in the load to that of which might flow under the matched condition is known as reflection factor. Okay, the reflection factor is mentioned by small k. It is nothing but the magnitude of I2 by I2 dash. Okay, so the formula for the K is this reflection coefficient already ZR minus Z0 by ZR plus Z0. So using that we solved 2 more problem also as a first question. Okay, reflection factor is 2 into square root of ZS ZR divided by ZS plus ZR. This is the reflection factor. Okay, then the next one, define reflection loss. So it's a important university question, 2018 and 16. So the reflection loss is defined as the number of nepers or decibel by which the current in the load under image matched condition would exceed the current actually flowing in the load. Okay, so how much current exceeded that ratio, we are calling it as a reflection loss. Okay, so the reflection loss is nothing but it is a if you want to mention the reflection factor in dB or Neper means it is called as a reflection loss. So you see reflection loss is equal to ln of 1 by k. The reciprocal of reflection factor, it is called as a reflection loss. So ln of 1 by k value you see, you just take reciprocal. If you want to mention in ln means this is Nepers. If you want to mention in decibel means you have to take 20 log of this one. This is the reflection loss. Okay, then the next one, define the term insertion loss. So insertion loss of a line or network is defined as number of Nepers or decibels by which the current in the load is changed by insertion. So if you are inserting some network in between the sender and receiver means because of the insertion, so how much number of Nepers or decibels by which the current in the load changes. It is called as a insertion loss. Okay. The next one, define input impedance and transfer impedance of the transmission line. So input impedance, you know, it's the ratio of sending end voltage to the sending end current. It is called as a input impedance. Transfer impedance means it's a ratio of voltage at the sending end to the current at the receiving end. Voltage at the sending end to the current at the receiving end. This is called as a transfer impedance. Okay. The next question, write down the expression for open and short circuited impedance of a transmission line. So if the transmission line is in short circuited condition at the output side, the short circuited impedance is at SC equal to Z0 turn H eta L. The open circuited impedance is Z0 cot H eta L, where eta is a propagation constant, L is the length, Z0 is the characteristics impedance of the transmission line. So if you are multiplying these two means we can get Z0 squared. Okay, so using this already, the third problem we solved using this formula. Okay, then the next question, find the attenuation and the phase constant of the propagating along the line whose propagation constant is given. Okay, so what is the relation between the propagation constant, attenuation constant and phase constant? Already you know the propagation constant is nothing but alpha plus j beta. Okay, so if you are representing the propagation constant as a complex quantity, the real part is called as attenuation. The imaginary part is called as phase constant. Okay, so here the propagation constant is given in polar. So okay, this is the given data. So you just convert this polar quantity into rectangle. So you may get the answer 2.19 into 10 to the power minus 6 plus j 1.048 into 10 to the power minus 4. Okay, so in this real part is called as attenuation constant. This imaginary part is called as phase constant. So alpha equal to 2.19 into 10 to the power minus 6 Neper per meter. So the unit for attenuation constant is Neper per meter. So the unit for the phase constant is radians per meter. Okay, so this is a one type of problem. And the next question, the open circuit and short circuit impedances of transmission line at 1500 hertz are 800 with angle minus 30 degree, 400 with angle minus 10 degree. Calculate its propagation constant. Okay, this is the question. So here the ZOC, ZSC given, propagation constant we have to find out. Okay, so you see this, that is if ZSC, ZOC is given means how to calculate the characteristics impedance means if we are multiplying and we are taking square root means we can get. Similarly, the propagation constant equal to turn H inverse of square root of ZOC by ZSC. So turn H inverse of, you just substitute OC divided by ZSC. So 800 ZOC. Here you see this is the open circuit. Okay, so open circuit and short circuit impedance you just substitute. So here we may get a tan h inverse of square root of 0.2 into square root of 20. Okay, so this is the answer. For this open circuit and short circuit impedance given means how to calculate the propagation constant. Okay, so thanks for watching my channel, and please subscribe my channel for more videos. If you want to learn all lecture videos related to this transmission lines and waveguides and transmission lines and RF system, in my channel, in the name of transmission lines and RF system, the complete playlist is there. In that playlist I posted that is unit wise, topic wise, I discussed all topics and problems also solved in that playlist. I will give link for that playlist in the description box. You can refer it. Okay, so thank you. We will meet in the next video with the second unit 2 mark questions.